Hey, what's up everybody? My name is Moss, and in this video, I'm going to introduce you to Horizontal Pod Autoscaling in Kubernetes. So first, I want to define what Horizontal Pod Autoscaling is and why you would use it, and then we'll jump into an actual example where we will implement a Horizontal Pod Autoscaler. And we'll monitor the impact of the autoscaler in the Splunk Observability Cloud interface. So let's say you have an application manifest defined like what I have here. If you take a look at line 12, you'll notice that the number of replicas for this application is 1. So this means that when the application is deployed to my cluster, it's going to be deployed with 1 pod. And this pod is simply running a PHP Apache server. Now, if I scroll down to the resources section on line 23, we can see the limits and requests specified for the containers that are going to be running in this deployment. So we're limiting the containers to 1 CPU core and 16 megabytes of memory. And then starting on line 27, we're guaranteeing an allocation of 500 millicores of CPU time as well as 12 megabytes of memory. Now I've already deployed this application to my cluster, and I've also deployed the Splunk OpenTelemetry collector to my cluster as well. And the collector is forwarding data from my Kubernetes cluster to Splunk Observability Cloud. So let's take a look at this deployment in the Splunk Ollie Cloud interface. From the home page, I'm going to navigate to the infrastructure page. And under the containers section, I'm going to select Kubernetes. These two entities are the Kubernetes navigators, and we've discussed them in depth in another video that you could take a look at if you're interested in exploring these more. From here, I'm going to select Kubernetes nodes. And from the dropdown here, I'm going to filter based on cluster name and select my cluster. So this is my Kubernetes cluster, and it currently only has 1 node. So if I hover over this blue square here, the node name is at the top of the metadata, and you can see that that identifier, that unique identifier, does match the same identifier you see here when I'm logged into that node. And then these green squares are the individual pods that are currently running on the node, and here is our PHP Apache pod that's running the PHP Apache service. So I'm going to select that pod. Now I'll be able to see more detailed information about the pod and the container that's running inside of the pod. If I scroll down on this page, I can see the current resource metrics for this pod and its containers. From here, we can see things like the number of active containers in the pod. And if I keep scrolling, we can see other metrics as well, such as memory usage. And memory and CPU usage are the metrics that I'm most interested in. If we take a look at memory usage specifically, you'll notice that when we hover over memory usage, we're at about 13.5 megabytes of usage, and that's about 85% of our allowed allocation. So 85% memory utilization is pretty high, especially if this is like normal traffic patterns. We're at 85% utilization. This gives us barely any room to burst if we had a sudden increase in traffic. And you're probably wondering why the utilization is this high in the first place for the server. Well, in addition to deploying this Apache server and the OTel collector to my Kubernetes cluster, I also deployed load generators to the cluster as well to create load on this Apache service. And if we scroll down to the CPU usage, top containers by CPU usage, you'll notice that the usage is right at 1 core, which is essentially 100%. Remember that we set the limit for this deployment to be 1 CPU core, and it's hitting that limit consistently. So it's probably trying to go above that limit, but being throttled. Now, there's a couple of ways that we can handle this particular scenario where an application is under resource pressure, like what we're seeing here. We can either scale the application up, meaning allocate more CPU, memory, disk to the application, or we can scale the application out, meaning we increase the number of replicas of this application so that each replica can consume and share the load of the traffic that's being received. You might need to use a mixture of both scaling up and scaling out to right size your application for the amount of traffic that you're receiving or the amount of resources that your application needs in order to operate. Additionally, you're not going to be able to scale out very easily if your application is stateful, for instance, if you're running a database. In this particular case with the Apache server, we can scale out very easily and handle additional traffic. Now, if we were to scale out this service manually, what we would need to do is navigate back to our resource definition for that Apache service and update the number of replicas to a desired number that we think can handle the current load on the application. We could also update the replicas through the command line as well. But this method of manually updating and scaling out the service is extremely inefficient. Think about if you had a target utilization value in mind when you were adjusting the number of replicas. So, for instance, our current memory utilization is around 85%. If we want the application running at, say, 50%, how do you know what the right number of replicas are? You don't really know that without trial and error. So you're likely going to be updating the number of replicas multiple times in order to get down somewhere close to your target utilization range. Nobody has the time to do that when your application is actively experiencing resource pressure and potentially causing performance issues for your customers. And that's why we have horizontal pod autoscalers, which will automate the process. And you just tell the autoscaler, I want the average utilization of memory for all of the pods in my deployment to be 50%. And then the autoscaler will figure out what the right number of replicas are to be deployed in order to meet that average utilization rate. So before we actually implement the horizontal pod autoscaler, I'm going to increase the number of replicas of the load generator and create even more resource pressure on the application. So I'm going to paste in a kube control command to scale the load generator replica set to 4 replicas. So now that the load generator is scaled up and we know that the application is under quite a bit of resource pressure, let's implement the horizontal pod autoscaler. I already have a draft of the autoscaler resource in this hpa.yaml file. So let's take a look at how we define a horizontal pod autoscaler resource. Right up at the top, you can see that this is using the autoscaling API, and the kind of resource is a horizontal pod autoscaler. So if you want to implement horizontal pod autoscaling, you need to create a horizontal pod autoscaler resource definition. And then we're also naming this autoscaler PHP Apache and associating it with the Apache namespace, which is where the Apache service is currently running. Now, if we take a look at the specification, on line 7, we can see the max replicas. Okay, so this is the upper bound that this autoscaler is going to create for the number of replicas of a target deployment. In addition to max replicas, you should also define the minimum number of replicas, which is defined on line 21 as just 1. It's good to set an upper boundary for the number of replicas, because if you're on like a cloud platform and you have a sudden burst of traffic and it spins up a large number of replicas, that could end up costing you quite a bit of money. So this is also related to cost control. Although you want your application to be performant, you don't necessarily want your costs to balloon out of control. Now, starting on line 8, we're defining metrics that this autoscaler should be measuring against when it's deciding whether or not to scale our deployment up or down. The first type of metric that we're monitoring is CPU usage. So you can see here the name is CPU, and then we're defining a target utilization. Okay, so target CPU utilization of 50%. And then we're also defining the same target metric for memory as well. So we're targeting 75% average utilization across all pods in a deployment for memory. And then starting on line 22, we're specifying the target resource that this autoscaler is going to be watching metrics for and deciding whether or not to scale that resource up or down. In our case, it's the PHP Apache service. The Apache deployment is actually defined as a stateful set, which I'm not sure is correct. It probably should be a deployment, but it's okay, and we'll leave it for now. Now, one thing that I want to quickly point out is that if we navigate back to the Splunk Ollie Cloud interface, you'll notice in the top right here 3 alerts, and these alerts are for container restarts. And if I click on the alert, we should be able to see that the container that's being restarted is our Apache service. And under the signal details, you can see the pod name as the PHP Apache 0 pod. And these container restarts began right around the time that I scaled up my load generator. So let's exit out of this alert and navigate back to our autoscaler definition. And I'm going to apply this autoscaler manifest to my cluster. So I'm going to paste in a kube control command, and then I'll hit enter. And then after applying that autoscaler, I should be able to see it in the cluster by using this command, get HPA in namespace Apache. And we can see here in the autoscaler the min-max pods, and then the current number of replicas, which is 4. So if we navigate back to the Ollie Cloud interface and we take a look at our cluster, you'll notice that those additional replicas of the Apache service are being shown here as well in the heat map. And I'm going to navigate into one of these pods so we can see the current metrics for the pod. So if I scroll down, we should be able to see the CPU and memory utilization. And you can see here that the memory usage is still pretty high at around 85%. That's above our target utilization rate. So what we should do is increase the max number of replicas, and I'm going to double it to 8. So I'm going to navigate back to VS Code, and I'm going to edit the HPA definition. We'll increase the number of max replicas to 8, and then save and quit. And then if we take a look at the autoscaler again, we should be able to see that updated number of max pods, and then you can see that it's already increased the number of replicas to 7. I'm going to navigate back to the Ollie Cloud interface to confirm the increase in the number of pods. And we should see the additional Apache pods show up in this interface pretty quickly. Actually, I noticed that the containers are still being restarted, and they're in a CrashLoopBackOff. And I suspect that this is because of the amount of load that's currently being generated. So I'm going to scale the load generator back down to 2 replicas. So I'm going to paste in that scale command and update the number of replicas down to 2. And then if we take a look at Ollie Cloud, we should be able to see those load generators being scaled down. Putting the pods in a CrashLoopBackOff state was not a planned part of the video. It was just a result of me increasing the number of replicas for the load generator too high. I know I'm going a little fast here, but I want to monitor the Apache pod that's in a CrashLoopBackOff state and confirm that after scaling down the load generator, the pod begins running normally. I think the pods that were in a CrashLoopBackOff were preventing the autoscaler from adding any additional pods. You can see now that there are 8 Apache pods that have been deployed. And if I navigate into one of the Apache pods, we should see the CPU and memory metrics look a lot better than what they were when we didn't have the autoscaler. You can see that our memory utilization is below our target utilization value of 75%. And then if we look at CPU utilization, that's also much lower than our limit as well as our requests. So it looks like the autoscaler is working as expected, and I'm going to navigate back to my cluster. The autoscaler scales both up and down based on the current utilization metrics. So if our load generator was terminated or reduced, then we would probably see the pods, the Apache pods, being scaled down to a lower number of replicas. I hope you enjoyed this video, and if you did, we'd love to hear your feedback. Thanks for watching.